Welcome back to our Fibrify Design Suite tutorial. In the last video we have created our first layup using the fiberline follower and the band generator. In this video we'll continue creating fiber prefabs using the contour infill and creating our second layup, and we will also create our final stack up consisting of these two layups. So as you can see here, this is the layup 1 that we have created in the last video. So let's go ahead and just hide it for now and show our plastic body, our model again. And now I want to show you the third fiber creation tool, which is called the contour infill. So go ahead and open this, and how this one works is basically the same as the fiberline follower. By holding down Control, we can select different input curves, which in this case are called external contours. So let's go ahead and select the external contour of our part. As you can see, as soon as we have selected a closed contour, the area of that contour is filled with a simple fiber pattern. Here we have different options to choose from. We have a simple fiber pattern, which means that every fiber band will be cut at the end of each fiber line, or we can choose a snake pattern, which means that instead of cutting each fiber band, the printer will perform a U-turn and reduce the amount of cuts. Here, this could save time and money in the end. Again, like the cutting curves worked for the fiberline follower, we can use the left Alt key together with the Control key for the contour infill to select holes within our external contour. And by doing so, you can see that these holes will not be filled with fibers. This is one way to do it. If we press Escape again, you can see that you can also, while still in the contour infill tool, select the whole surface at once. And by doing so, you can see that you can achieve everything that I've showed you with just one click to make things easier. So let's have a closer look, or let's look further into our options here. So we've decided to go with a snake pattern. Another option here is the parameter, which means that we can either choose to have an external parameter reinforcement, or an island or hole reinforcement, or all edges. So maybe to show you this, we can now integrate a external fiber following the external contour that we've selected, or we can integrate fibers around our holes that we have selected. For our tutorial, let's just go with a hole reinforcement, a single hole reinforcement here, and have the rest just be filled with this snake pattern. The last option I want to show you here is that you can of course change the infill angle. So instead of 0 degrees, you could go ahead and choose 90 or whatever angle you want. For this tutorial today, let's choose 90. And again, we can just leave the Z position as a default value here at 0, meaning that our fibers will be created on the first layer available. Go ahead and create these fibers. Fiber solids have been updated. Again, Escape and S to leave the tool. Let's hide the plastic body again real quick, and now we can see here the fiber solids have been created. We have again a new component within our structure tree, the contour infill 1. And when we have a closer look here, we can see that usually fiber solids are created in this green color that we can see here. In some cases, as seen here, some fiber bands are created in that red-orange color, indicating that these fiber bands are too short to print. So in this case, these fiber solids, when being exported, will simply be transformed into a plastic material. So as I said, this red color is for indication. You don't have to worry about it. The software will take care of it and print these single fiber bands that can result of these contour infills just as plastic. Okay, so this second layup went quite quick. To keep an overview, what we can do here, so to have everything nicely structured in the end, we can again create a group prefab, just select the single contour infill again and create that group prefab. Press S again to leave that group prefab, hide the contour infill 1, rename that group prefab to layup number 2, and now we have our 2 layups that we were set out to create, our layup 2, which is the contour infill, and the layup 1, which was created in the previous video. We can now hide these 2 layups, maybe just hide that sketch plane as well, and we can then proceed and have a look at the vertical distribution or stack up tool. So here a second window is opening, and on the left we can see we have all the available fiber prefabs which we can choose. We have the single prefabs, the line follower 1, surrounding band 1, etc. But we'll also have our renamed group prefabs, the layup 1 and the layup 2, which we now want to vertically distribute. In the middle, we actually have these different rule parameters by which we can vertically distribute a certain prefab or a layup. Here at the top, we have the starting position, which we can choose. We can then set the amount of repetitions. So how often will this layup or prefab be distributed, and then we can set if some layers should be skipped, meaning that we can say repeat this prefab, for example, 5 times, but only every second layer. So now when we have a closer look at the start at parameter, there are like 2 different ways of doing it. So at the moment, this is set to start at prefab Z position, meaning that this vertical distribution that we want to perform will start at the current Z position of the selected prefab. This means when you were to when you change these default values in the Z positioning for each prefab that we've created, this would be the start position here. So this is more of a local approach. If you would like, or if you like, you can already, by creating these prefabs, have them placed strategically at a specific position in the part, and then start a vertical distribution from there. If you don't want to do this, you can simply choose either just start at a specific layer height or start at a specific layer which is including a specific height of your part. So we can choose the layer number, meaning that despite the current position of our individual prefabs and layups within our part, we can set a starting layer individually. So for our vertical distribution for this tutorial, we want to do a alternating layup between these 2 different layups that we've created, an alternating stack up in the end of these 2 different layups. So we can say we want to start with that layup number 1, that contour infill, and have that start at layer 0. We can now could go ahead and say how many times we want that layer repeated. We do know that our part is 10 millimeters in height, so we could calculate with a layer height of 0.25. This would leave us 50 layers of space in that part, meaning for that alternating layup stack up, we were able to actually repeat this layup 20 times every second layer. But to make it a little bit more, or to make it easier, we have a second option here. Instead of just repeat for a specific number of layers, we can choose repeat until z equals, meaning that we can put in our part height, which is 10 millimeters. And now what the distribution tool does, it starts again at layer 0 and distributes this layup every second layer until that 10 millimeter mark is reached. As soon as we've set all the rule parameters, we can add this new rule. This new rule will be visible here in the defined rules section, and also, as you have just seen, these fiber bands or these fiber layers are created instantly. So now when we have a look from the side, we can see that we have that layup 2 created up until a height of 10 millimeters every second layer. The same we can do for the layup number 1. We leave these settings here, repeat every second layer and repeat until we reach that 10 millimeter mark, but have this one start at layer 1 to achieve that alternating effect. Also add this rule, and as you can see here, the rule is added here in the defined rules section and also automatically implemented here in our design window. By hiding the central curves, we get a better look here, and we have now successfully created our final stack up for our model that we want to create. This is the end of this video. In the next video, we will take a closer look at the hybrid final part and prepare the model for export. Thanks for watching. See you in the next video.